Hello everyone. In this video I just wanted to make a little bit of a showing of how Undervolt affects the thermals and performance of this machine. Well, actually I think only the thermals, we will only have time for that. I just reprogrammed this machine with the C314 programmer, and I can now unlock the Undervolt on this firmware. This is late 2013 Haswell machine, which is was already updated to Big Sur. So we have the latest firmware for this machine, which is 4.7.8. So this is the one where Apple locked the undervolting, like around 2020, and we had undervolt unlocked, and now we unlocked it. But we'll now start with a zero offset, so everything is zeroed out. There is no undervolting currently going on, and we will see how much power we're using running Cinebench, and then we'll input the undervolting and see how that changes. And also we'll also take a look at what happens when the system crashes. So we're now starting Cinebench. This machine has been already taken care of in regard to cooling, so there's a very good thermal solution going on, and we had thermal pads on the bottom and new thermal paste. Even though this machine also has a broken pin, which is very usual on these 2013 and 2014 machines, where the cooler one of the cooler holders falls off, snaps out. Well, we fixed that, some kind of ways that I maybe show you later. But anyway, so we're currently running at around 35 watts, and our frequency is peaking at 2.8. This is the maximum frequency for the CPU. This is a very power efficient CPU because it's the lowest model. It's a 2 GHz one, and doesn't pull that much power. We'll see now what happens when we actually run the undervolting. And what will happen here is that we will have a drop in power consumption here. So we went from about 35 to 30 something. We now had 540 on the score, and as you can see, the average power draw of the entire package, which is the darkest one, it was about 35. So we now let it cool down a little bit, and then we'll repeat the test with the undervolting already applied, and then we'll see what happens when it crashes. And here we are back. The system cooled down. One thing to notice, cannot notice, one thing to note is that the whole machine is now quite hot, because the way we build the systems is that we make sure that the heat transfers to the aluminum on top here with some thermal pads, and also heat spreaders, metal heat spreaders. So this is not like one-to-one example, because the system is not fully cool, but we'll see the difference anyway, I think, because we're running with a huge undervolt. So the machine will start with a much lower power consumption. As you can see, it's now taking 30 watts, so we shaved off 5 watts of the power. So that means the power consumption is also climbing very, very slowly, and the fans are not ramping up at all. You can't hear anything. There are other machines in the room that are running tests, and they are making more noise. Apple designs their machine in a way that they started the fan only when it hit 95 degrees or 90, I don't remember, depending on the single, like, of the year and everything, but that's what averages for them, because they don't want them to run loud. And another thing that I wanted you to notice is that there's a slight power increase as the temperature increase, and that is because metal, the silicon inside and everything, loses conductivity as it gets hotter. This is also why when you run like extreme performance test, they do that with liquid nitrogen and stuff like that, because as cold as the chip is, the lower energy it needs to complete the tasks. So as you can see, we scored the same exact number of points on the test, but we ended up with still around 30 watts of power consumption, and the machine never ever started a fan or reached more than 80 degrees. And that is what undervolting does. You get much more efficient. operation. We shaved off 5 watts. Now let's try to input something that is, I guess, could be like on the verge of instability, which means that it might crash as soon as I type this in, but it might also like run the test for a tiny bit and then crash. So this machine, from my personal experience, usually take around 100 of offset to crash. So this has not crashed, but it could crash during the test. Let's see how 110 does. So we shaved off another 1.5 watt, maybe 2, something around between 1.5 and 2, and it's not crashing. This might crash maybe in some other kind of workload, because different parts of the chip react differently to the voltages, and you don't know which part of the chip has the lowest quality silicon, like has the worst defect in it. So we don't know, maybe the Cinebench R15 will not pick it up. Also, Cinebench R15 is not like a super heavy stress test. There are much heavier stress tests that we can run, but they are not designed to run on macOS. So I actually usually use Windows to test for instability on even on MacBooks, but that's another thing. And yeah, I might also run the OpenGL test, which is the graphical test, and see what happens. It didn't crash. Yeah, it's interesting. This machine might be quite lucky. There are some machines that crash as soon as you type 100, for example. So this machine will usually then be stable at around 75 to 80 in the end. But I mean, there's not a written rule. So we got a slightly better score. Let's now run the OpenGL test. OpenGL test is more of actually of a single core CPU test, but it also involves a little bit of tiny GPU usage, especially since we're running off the integrated graphics, which is very low performance. So it will actually load the GPU part. When you do this offset, the undervolting, you actually give input different values to different parts of the chip. And in my experience on this family of machines, you usually get a lower offset for the CPU than you get on the GPU and the cache. We're not crashing, so this might be a very lucky sample. And you may see now that the light green line, which is referring to the graphics frequency, is much higher than before, because previously we were running a CPU test where the CPU was running at maximum frequency. Also, another interesting thing is that the core frequency is now maxing at 3.2, and that is because we are only using a single core, and that boosts to a higher frequency. But that's another story. That's a more, it's another topic. You might not know about this. We finished every test, so everything is fine. Let's give this machine some insane undervolting, like 150 on the GPU, and I should get a freeze instantly. No way, it's keeping up. 150. That's interesting. I know that the undervolting is working because we actually got the power decrease, but it's not crashing. So this is interesting. It will probably crash. Yeah, it crashed, I think. I mean, I guess the GPU crashed. Maybe. It's struggling. I guess we're getting in like this gray zone where you actually end up with the instability, but the system is not crashing yet. This is only usually this is much easier to accomplish when you actually undervolt the GPU, because the GPU is rendering the screen, and you might end up with some parts of the screen that are actually showing errors, but the system is still going. But it mostly seems like the system has crashed. I mean, the graphical part of the system. Yeah. So the test crashed. You can see that, and the GPU maybe tried to load something. I guess the system now completely crashed. Yeah, you saw some glitches. You can see that. So this is like an intermediate situation where you get like glitches. Yeah, here it is. You can see the glitches. So we crashed the GPU. The system is still running. So probably what is happening now is that the graphics driver is reloading. It's trying to reload, and like it's crashing and loading up, and the system is on this weird situation. It's fun. But yeah, we got it where we wanted. And I guess that is all for the video. I don't know. Let me know if you find it interesting and fun. Oh yeah, I might show you the problem with this machine. So here it is. You can see that this one is gone, like it detached from the motherboard. And what I did is to put some plastic here so that the bottom cover actually pushes down only this one pin, and then I put more thermal pads on this side of the cooler, so that the thermal pads also provide pressure, and I slightly loosened up the other 3 screws so that I can get a more even pressure on the chip, and the thermal paste doesn't leak out on this side. Yeah. Also, another thing is to notice that my colleague got a wrong thermal pad here. These are thermal pads that are made to transfer the heat on the bottom here. Yeah, I guess this have to align with the height of this and touch here. I also need to take out this material also on this part. And that is all for the video. Ciao.